As per our previous discussion, okay, hysteresis loss, because of hysteresis loss my no load current is going from here to here, and because of eddy current loss IE is coming into picture, total no load current is going to be I01. Okay, now this I01, if I want to model, okay, now this, let me divide this I01 into two components. Okay, so one is in line with voltage, another is at 90 degrees with voltage. At 90 degrees with voltage, let me call it as I mu. At what is in line with voltage, let me call it as IW. Okay, such that this particular I01 I can divide it into I mu plus IW. Okay, now what is this I mu? What is this IW? I mu, we call it as a magnetizing component of no load current. In the sense, for example, maybe in the materials, okay, we are having three combinations, not four. Magnetic material will be there, electrical conductor will be there. Okay, for example, if you think of copper is an electrical conductor but non-magnetic material. Okay, if you think of iron, it's electrical conductor and also magnetic material. Now if you think of wood or maybe air, okay, so electrical insulator means my wood block is going to be electrical insulator and also non-magnetic material. In the sense, non-magnetic electrical insulator, we have example wood, and magnetic electrical conductor is there, that is iron, and means what do you say, electrical conductor non-magnetic material, copper will be there. Okay, but we don't have any material which is magnetic electrical insulator. Okay, for example, if you think of wood or maybe air core transformer or air core inductor, we say, now if you think of air, okay, air is electrical insulator, so electrical property of eddy currents will not be there in air. And air is non-magnetic material, so the moment it's non-magnetic material, magnetic property of hysteresis loss will not be there. Now if you think of copper non-magnetic electrical insulator, so as it is in copper, as it is non-magnetic material, non-magnetic material, hysteresis losses will not be there, and as it is electrical conductor, eddy current losses will be there. Okay, now if you think of iron, both hysteresis and eddy currents will be there. Okay, means that my iron is an electrical conductor, so eddy current loss will be there, and magnetic material, so compulsorily hysteresis loss will be there. Okay, now if you want to, what do you say, eliminate eddy current loss by keeping the magnetic property, it is not possible, because we don't have any electrical insulator type of magnetic material, we don't have. Okay, now anyway, see here, if my magnetic material don't have hysteresis and eddy currents, okay, so as I told you previously, hysteresis is non-linear. Okay, so the moment hysteresis is non-linear, if hysteresis is not there, means that non-magnetic material. Okay, and for example, eddy current is not there, means that electrical insulator. Under that condition, means we are going to get our network theory simply, because the moment hysteresis is not there, automatically it will become, what do you say, linear. So if hysteresis is not there, eddy current is not there, my no load current would be of this much, because I mu means if non-magnetic electrical insulator, my no load current will be in line with pi naught. Okay, so at that time what my current would do, current would set up the flux. So my I mu can be called as magnetizing component of no load current, which will try to set up the flux in the magnetic material. And here IW, if you see, means for example in no load current, how much will be the no load losses, in the sense total core loss is going to V1 I01 cos theta naught. Now I01 cos theta naught is IW only, so IW is called as watt component, okay, or loss component can be said. Okay, so see here, this is going to be magnetizing component of no load current, and this is going to be watt component or loss component of no load current. Now let me model this. For example, if I01 is entering into the circuit, that has to be divided into 2, because it is forming KCL, it is dividing into 2. Okay, so one I can think of I mu, another I can think of IW, such that I mu plus IW is I01, I mu plus IW is going to be I01. Now I mu, is the component of current which is lagging behind voltage by 90 degrees. Okay, so I mu is the current flowing, and if I want to model this I mu with respect to voltage V1, I mu is lagging behind by 90 degrees, so it has to be modeled with inductance. Okay, now let me call this as X0, and voltage across this should be V1. Now what is happening with respect to voltage? Current is lagging behind by 90 degrees in an inductor. Now if you think of resistor, okay, because IW and V1 are in line. Okay, so IW and V1 are in line means that it should be modeled with resistor. Okay, voltage across this should be V1. Okay, now means V1 and IW should be in line or not, and V1 and IW are in line only. Okay, now this is going to be the model. Now, like what are the parameters depending upon hysteresis only or eddy currents only or both? Let us discuss. Okay, now this is going to be I01, this is going to be I01. Okay, so for this I01, component of I01 in line with pi naught is going to be I mu. Okay, now I mu component, will it be decided by hysteresis only or eddy currents only or both? If you compare, it will depend upon hysteresis only, because eddy current component is at right angles. Okay, so for example, this is hysteresis component of I01 in line with pi naught component is going to be I mu only. So we have to remember that I mu will depend upon hysteresis only. Because in future questions will come. Okay, in old IAS questions are there, and GATE questions are there. In order to solve that, it is required. Okay, now this is I01 component in line with pi naught is going to be I mu, and I0H, because of hysteresis, component in line with pi naught also is I mu only. So I mu is depending upon hysteresis component only, and it is independent of eddy current component, because eddy current component directly in line with V1, as we discussed previously. Okay, now if you think of IW will be decided by serial. IW is going to be this I01 component in line with V1 is going to be IW. Okay, so in calculating this IW, if you observe, I0H is giving some component I0H and a component in line with V1, and IA component in line with V1. So IW will have both hysteresis component I0H in line with V1 and IA in line with V1. So IW will be decided by both hysteresis and eddy currents. Okay, now as I told you before, okay, hysteresis is non-linear. Just remember that way. Hysteresis is non-linear, eddy currents are linear. Now I mu means magnetizing component of current is decided by hysteresis only. Hysteresis is linear or non-linear? Non-linear. Okay, and IW will be decided by both hysteresis and eddy current. Eddy current is linear, but hysteresis is non-linear. So IW component also will become non-linear. Okay, non-linear means that now this particular R0 and X0 are going to be non-linear. Okay, already we discussed in our previous session that if anything is non-linear, parameter values will change depending upon the operating point. So variations will happen between R0 and X0. Okay, now depending upon the operating point here, okay, R0, X0 values will be changed. Please come out of network theory. Okay, in network theory, if I draw one resistance, that resistance value may be constant, but in machines it will not happen. If it is linear, means component values will not change, but if it is non-linear, depending upon the operating point, my R0 and X0 values will change. Okay, how these are going to be changed, we will solve with problems. Let me repeat, then you will understand. Thank you.